For the next 30-ish minutes, I'm going to annoy the cameraman by going over and back. But I'm going to try and talk to you about what PyKX is, why we developed it, where it is now, where it's going, and ultimately everything in between. What I'll try and do during that time is provide enough of a background across what we've been doing and what we've been trying to achieve that there's room for questions at the end. But to start with, I'll talk through what I'm going to describe. It's three parts, basically. The background about what we're doing, what the latest is, as Peter mentioned, we just released PyKX 3.0, and what the future looks like. To start with, we need to go back to what PyKX is, why we developed it, and ultimately where it's used today. So there's lots of clients in the room today that use PyKX on a daily basis for data analysis, for retrieval of data from existing KDB infrastructures, and ultimately are in a position to kind of maximize the value of data that's in KDB+. But what is PyKX? Ultimately, PyKX was just designed and kind of envisaged as the most comprehensive integration between KDB+ and Q KDB+ and Python that has existed to date. Prior to PyKX, there were three versions of integration between KDB+ and Q: QPython, Embed Py, and PyQ. PyKX basically is intended to replace all of them as a single package that can help you to accelerate use of Python and KDB+ within your workflows. In terms of how we kind of envisage it from the perspective of users of Q today and users that could use Q in the future, it's really as a gateway. So users of PyKX really get the option to see and the ability to see where we get performance benefits of using the data format KDB+ and ultimately Q under the hood, but in a way that's familiar to them and ultimately gives them the confidence that the data format itself is workable for their use cases and for their quants that are coming out of university today or are coming into their workloads. Okay, so why? Why did we develop it? There are kind of 6 key things that we were looking to achieve at the initial stages of PyKX's development that ultimately still hold true today. Some things have changed, and I'll talk through some of that, and there'll be additions onto this in a later slide. So, starting at the top left, interoperating with the Python ecosystem was a key part of what we were trying to do at the very beginning of this. So conversions of data to and from the most common Python data formats as fast as possible. So pandas, pyarrow, numpy was pretty much a key initial requirement. In previous iterations of integrations between KDB+ and Python, there have been limitations on the way and what data formats users could interact with. We wanted to try and limit that as much as possible so that users that needed to get data to and from the KDB+ format could do so in a way that made sense for the algorithms that they were developing. On top of that, integrations at a very low level with NumPy and Streamlit give us the ability to help users to plot data and run functions on KDB+ vectors in a way that is common to them. So a user of NumPy can run np.max and pass in a KDB vector and it'll just work. They'll be able to do that. The last piece is on the integration side of things. So Jupyter Notebooks are very common in how people develop today. We've got really tight integrations with Jupyter Notebooks that allow users to develop Q first, to have access to the Q keywords, and basically be in a position to work at that hybrid layer between Q and Python. Top middle, creating and managing databases. So one of the things with KDB+ that some people get scared of is when they start to get to the point that they need to modify a column on an on-disk database or add a new partition of data or add a new table to a database. One of the things that we've done in kind of previous versions of PyKX, and we've been releasing it now as a kind of I suppose a final version of it, or at least the final production iteration of it, is for creating and managing databases. So running database maintenance operations for deleting columns, applying functions, those things that you expect to be able to do on your database, you can do now, Python first. Operating on in-memory data, Python first, which is quite hard to read because of the text. PyKX basically provides an API for integration with a pandas-like syntax. So users that are dealing with a PyKX table, which is ultimately a KDB table under the hood, are in a position to run pandas-like syntax against it. So running iloc commands, running max commands, running aggregations, basically to do the basic data science tasks that they expect to do in a Python-first way. One thing that's worth noting for PyKX, which is very different than it would be for most Python libraries, is that we already have pretty much all of the deployment mechanisms that one would expect or need that we have to basically surface. So in lots of our clients run in cloud environments. They run Q servers as their main data sources. They run Python servers. They have IPC connections. Essentially, what we wanted to do with PyKX was interact with the existing Q infrastructures to make it as easy as possible for users to hook in Python functionality into their infrastructures as needed. That means a couple of different things. It means helping to replace QPython by making it faster, but it additionally means having an embed Py style version for embedding Python onto a Q server, and then adding functionality to basically speed up the process of running Python on your servers. Another important piece, and one which is somewhat overlooked from time to time, is because of the way that PyKX operates, it basically allows you to run Q anywhere where Python would run. So if you're licensed to do so, you can run it in Databricks or Snowflake. You can run it on any cloud environment that Python would normally run. But it really gives you the ability to bring your Q analytics to the data where the data lives for your infrastructure. And then the last thing is replacing existing solutions. So I mentioned there were 3 previous versions of Python integration with KDB+. PyKX allows modes of operation that replace all of them, which gives you the ability to reduce TCO on ultimately managing the dependencies. If you're in a large firm that requires IPC and embedding Python inside of a Q process, and your quants want to run in Python environments, you have the flexibility and ability to do all of those with a single solution. So where is it used? Ultimately, on the left-hand side, there are 4 key areas that we kind of describe how it's used by users today. So it's used for democratizing infrastructure. If you have Q infrastructure today, you're basically giving your Python developers the ability to access it and to run analytics that make sense for them. For product modernization, for users that use dashboards, for example, there's a Python integration now with it, which uses PyKX under the hood. PyKX is essentially prevalent within the KDB Insights enterprise space, and recently we had an update to the Delta platform, which allowed PyKX also to be run. Flexibility in deployment, then, I suppose, is next. For Q users, PyKX under Q basically gives them the power of Python and its libraries without needing to leave Q. I can't really show that here, but there are modes of operation on PyKX which provide you the ability to basically write Python functions and ship them to the server, have them execute and return the data back to a user without them really needing to know that you're running separately remotely. And then streaming applications. So if you're running TIC infrastructures today, being able to use the embedded version of PyKX basically means that you can bring your Python analytics to your high-performance streaming workflows, and provided your analytics are fast enough, you're in a position to kind of augment what you're able to do yourself. Okay, so that's what it's used for, and then how are users in production using it. So I'll go through it. Client names in one case are provided, in the rest they're kept secret. So PyKX has basically replaced an existing market position tracking solution in one of the major banks. Previously they'd been using Pandas, doing upserts into Pandas data frames in order to manage their positions. PyKX multi-threaded is now doing that for them. In one case, one of our pharmaceutical clients has replaced Spark for large-scale outer joins with a 9x improvement, which for them is great because they're dealing with very, very large tables. Access to PyKX and Citadel, who's the one I can talk about, have basically meant that for a lot of their directed acyclic graph workflows, they've gone from run times of minutes to milliseconds, replacing NumPy and Pandas operations, and significantly reducing the CPU loads for their systems. There's a YouTube video on that, which we can, I'm sure that we can also send out later on. User the interface for the functionality generally on database creation and management are basically trying to offload for their users the need to have queue expertise at the kind of database management layer of it. So there's a lot of end-of-day operations that some of our clients do to rescale their data and to move it to a position that it's operable for following days. That job had to previously be done by queue developers, but now those queue developers are able to do more high-performance tasks or things that provide more value to the business generally instead of managing the database operations. Okay, so obviously Python is the thing that I like talking about in a lot of this, but really Q and PyKX together is really the solution that a lot of what our users do and what we recommend to users is ultimately. So better together story. In PyKX's case, users of Python now get access to Q's performance and efficiency on one hand. That provides the ability for us to be in a position that new users to the technology can see why people have used this for as long as they have. Collaboration between Python and Q developers works bidirectionally. So if you are a Q developer and you develop Q libraries, you can make those available to your Python users and they can make function calls that to them appear Pythonic, but ultimately you're calling Q under the hood. And in the reverse case, if you're a Python developer and you've developed an analytic that's using our APIs, you're in a position to ship that to Q so that the Q developers can get benefit out of it too. This kind of harmony between the two gives you a best of both worlds kind of situation. You're in a position that as a Q developer, I can get access to the Python libraries that are available, and the reverse case for large organizations that have lots of Q. The Pythonic interface for Q functionality really does provide a lot of that. So Python developers can easily access, visualize, and manipulate the data using a Python API. They can integrate with TensorFlow and scikit-learn by converting the data to a relevant format that makes sense for them. But you're not kind of constrained in how you develop. Users can build infrastructures and build functionality that kind of works for them in whatever shape their problem is. And then the last piece is opening up Q to the AI and data science community. Most of the people in this room will know that one of the key strengths of Q and KDB Plus is its ability to manipulate large volumes of data and filter it very quickly. In Python, that's, for lots of libraries, not something that's a particularly strong element of them. Ultimately, we're trying to provide a degree of synergy for users that can take data at very large volumes, filter it down, and then pass it across to Python to let Python do what Python does best, which is benefit from the open source community and Python libraries that are produced on their side. Okay, so current responsibilities of a Q engineer. Right now, a Q engineer generally is full stack. They basically will have specializations, but they deal with the low latency, low frequency data ingestion, basic data storages, basic queries, intermediate queries, very high performance, scaling, infrastructure development, monitoring, maintenance. Basically anything that a user would expect to need in a full data science solution, Q developers need to do it right now. The vision in a lot of ways for what PyKX provides is the ability to move the Q developers' responsibilities to encompass those things on the left-hand side if they need to, but be in a position to focus more on the high-performance elements of things and be in a position to ultimately get the most value out of the engineers themselves. Q developers are best at being able to develop high-performance analytics and calculations and scale their infrastructure, but they shouldn't need to worry about building basic APIs or basic integrations or onboarding a new Parquet data frame, those kind of things into a KDB database. It should be possible for somebody else to do that. Okay, so I've talked about background. What's the newest thing? So Peter mentioned we released PyKX 3.0 on the 12th of November last week. What is it? So PyKX 3.0 is the culmination of 6 months' work by the development team. It covers a significant number of features, but the two main ones that are of interest to most people are Pythonic query API for querying in-memory and on-disk databases. This API is a significant extension to how we facilitate querying of KDB databases that are partitioned or splayed and stored on disk and memory mapped, or are in memory and available as normal tables. The API is designed to be as familiar as possible to a Python user, ultimately to give them comfort in trying new things and essentially iterating themselves without having to worry about needing to know Q on day 0. The big focus of the API in comparison to how other APIs work in the Python space is extensibility. So we know on our development team side that we don't know everything that you all do. It's a very secretive world in finance, and we're not going to be able to ask you specifics about the functions you write and how it is that they operate. So what we wanted to provide was the ability for you to extend the APIs to get into a position that you're comfortable providing new functionality to your users in a way that's familiar to them without having to come to us and say, can you add a function for min-max scaling data or whatever the operation is. And then the second piece is Python first streaming workflows. So Python's very bad at streaming. Q is very good at streaming. So what we've provided with the 3.0 release is a new way to initialize ticker plant infrastructures and basically extend them. So there's a basic tick version that allows you to spin up a ticker plant, an RDB, a HDB, add chain ticker plants, add gateways, add custom APIs, add custom query APIs, add real-time processing APIs, all Python first, and be in a position to kind of prototype things. So we don't envisage this specifically as something that would be build an entire production system on, but it could be something that users can use for backtesting or for testing whether their API will work with the schemas they have available. But importantly, it's all just tick. So under the hood, the way that it's actually operating is we've provided hooks into tick.q. We've made it available for Python users to be able to deploy Python analytics to their ticker plants and to be able to basically coordinate and set up these things without initially needing to know Q. So I mentioned 6 months of work, so 2 features aren't enough. What else is in it? I'll skip through a lot of this. Some of this is specific for some users, but there's help functionality provided for Q keywords. So if you do help on kx.q.max, you'll get an example of what max looks like for a Q user. You'll get examples of what rand looks like moving averages. Specifically important is the top left corner. So beta features promoted to production basically covers off 6 main features. The database maintenance creation functionality that I mentioned before has been moved from a beta status into something that we would be willing to stand behind users using. Compression and encryption APIs, Streamlit integration, remote function execution, which essentially allows you to operate locally but run your Python logic on a Q server, and a multi-threaded mode of PyKX are basically now all promoted to production. So to focus on 2 of the features, the 2 main ones, the Pythonic query API basically allows you to run selects, execs, updates, and deletes using a Python first API with Pythonic syntax, the ability to pass Q variables around. You can construct complex queries against it, and you can register your own functions. So on the bottom left, you'll see broadly what that syntax looks like. Essentially, the important parts are the kx.column object. So the kx.column object provides us the ability to add chained functions off it. So kx.columnPrice.max would be max price in any normal query. Rename is the assignment of max underscore price to the max of the result of that. But it's important to note on that a lot of the kind of magic of what's going on is going on in the parse layer for us on our side. So you'll see in the where clause there is a greater than for greater than 500 to find a filter on the data. We're also doing an is in, so if the symbol is in a list that's provided and we're chaining it together with ands. So overloads of Python's dunder methods basically give us a full Pythonic API that users can build and compose themselves. The value, I think, speaks for itself to some extent, but ultimately its intention is that it kind of lowers the barrier to entry for Python users coming in. So while this operates as it does, it really ultimately boils down to a functional Q-SQL statement that's running under the hood. So that operation runs both on in-memory data, but also data on disk. The intention with it really is to be as significantly impactful to users as it's possible for us to be without compromising on the performance of KDB+. And then the last piece, for the Python for streaming workflows. Ultimately, the bottom syntax there, which should be slightly indented, is the functionality that's needed in order to produce a ticker plant RDB and a HDB workflow that a user can basically start themselves. So the trade variable and the quote variable are schemas for the trades and the quotes. DB is the location of the database that exists. Log directory is the location that my logs will be persisted to, and basic.start basically starts everything up, chains it all together, and then you have a port that you can push data to that will ultimately be persisted. As I mentioned, you can augment that with the addition of chain ticker plans, additional real-time processors, complex event processors, gateways that query across them, and the documentation contains examples of all of those. The value really, as I kind of alluded to, is really in kind of the day zero testing of the technology, being able to be in a position that you can validate that the ingestion workflows that are provided by KX can handle the data volumes that you're expecting in terms of being able to test a single node version of a ticker plant. Or you want to develop an API with specific schemas that you have, and you want a quant to be able to say, I want you to onboard this additional data set. This is its schema. Let me show you that it runs the way that I expect it locally so that you can move it to production. And then the future. So there's a lot of things that we can do, and there's obviously a lot of things that we have done. But the roadmap as it stands right now contains really two kind of main things. So we're enhancing the database management functionality to support splayed tables and basically be in a position that you can maintain smaller data sets. Right now it's partition databases only. In addition to that, there's performance enhancements for conversions. So this should come out in PyKX 3.1, and hopefully I'll have a beta version out in the next couple of weeks that'll be available for Linux users, but that should speed up the performance of converting from pandas to Q by about 4 times. It's done a couple of different ways. We've basically migrated the conversion stack down to C instead of using Python. And additionally, we've multi-threaded the conversions from pandas to Q. Expansions to more data formats are obviously welcome. If users want specific data formats, we can add it to the list. And then integrations with the broader KX ecosystem. So making some of the things we produce right now more easily available to Python users. A good example is the ML toolkit, which we've provided open source for years, has been retrofitted to support PyKX as a backend as opposed to embed Py. And then the last piece, I suppose, is how our releases are shaped. So we don't work in isolation, right? We have lots and lots of users that are using this every day, and lots of people that provide us feedback generally. That accounts for about 70% of what defines our roadmap. Ultimately, interactions with users are the way that we learn about what the problems are with the library. 10% is based on our own understanding. So we spend an awful lot of time thinking about this stuff. A lot of the team have domain expertise in Python or data science or KDB+, and kind of blending those together gives us a pretty holistic view on what we would expect or need as developers on the flip side. And then the last piece is on usability testing. So Johnny from Data Intellect is here. He's kindly led a few of his consultants loose on PyKX over the last number of weeks. And working with new users of the library gives us an ability to figure out where the hard edges are on the work that we do, the things that makes it easier for you to onboard. So if somebody tried PyKX 8 months ago, their experience now should be significantly better because we're constantly intending to iterate. Okay, and that's me.